Okay, let's move on further in chapter number 8, the Indifference Curve Analysis by Higgs and Allen, towards the marginal rate of substitution. The concept of MRS is an important tool of indifference curve analysis of demand. The rate at which the consumer is prepared to exchange good X and Y is known as MRS. We already know change in Y divided by change in X, basically the slope of ICs uh, is MRS. Uh, in our indifference schedule 1 above, which is reproduced in table 8.2, in the beginning the consumers give up 4 units of good Y for 1 additional unit of good X, and in this process his level of satisfaction remains the same. We already saw this here in the okay, it's I think shown again here. Yep. It follows that 1 unit gain in X fully compensates him for the loss of 4 units of Y. It means that um, at this stage he is prepared to exchange 4 units of Y for 1 unit of X, which can be seen here. So 12 minus 4, 8 for 1 unit of good X. Therefore, at this stage, consumers' MRS for X and Y is 4. So the rate of Y that he's able to give up in order to get 1 more units of X is 4 by 1 equals to 4. Thus, we may define the marginal rate of substitution of good X for Y as the amount of Y whose loss can just compensate the consumer for 1 unit of good X. Very wonderfully explained. For if somebody doesn't know MRS for the first time, they're hearing this term, this is the best, most easiest definition that you can come across for MRS. In other words, MRS of X for Y represents the amount of Y which the consumer has to give up for the gain of 1 additional unit of X, so that his level of satisfaction remains the same. This is important, right? So is his satisfaction is going to remain the same, which is why we're saying that it's on the IC, and which is why it's MRS for the whole IC, right? The slope of the entire IC. In table 8.2, while the consumer moves from combination B to combination C in his indifference schedule, he forgoes 3 units of Y for additional 1 unit of X. So now from 8 is coming to 5. So now it's 3. Okay, so it's written here as well, right? For 1 more unit of good X, so from 2 to 3. Likewise, when the consumer moves from C to D and then from D to E in his indifference schedule, the MRS of X and Y is a 2 and 1 respectively. How to measure MRS of an indifference curve? Consider figure 8.3 when the indifference curve is shown. When the consumer moves from point A to B on the indifference curve, he gives up AS of Y and takes up SB of X. Gives up AS of Y and takes SB of X. I think it's understandable from this triangle-like structure. And he remains on the same IC, or in other words, at the same level of satisfaction, because IC is equivalent to same level of satisfaction. It means that the loss of satisfaction caused by giving up AS of Y, this because it's coming down, you're giving up this to come to S, is able to be compensated due to the rise in the quantity of X, which is SB. So and takes up SB of X and remains with the same IC. It means that the loss of satisfaction caused by giving up AS of Y equal to the gain in satisfaction due to the increase in good X by SB. It follows that the consumer is prepared to exchange AS of Y for SB increase in X. In other words, MRS of Y of X for Y, MRS XY is equal to AS by SB. Okay. Now a small change in the amount of Y, such as AS along the indifference curve, can be written as delta Y. Okay. um, and the change in amount of X is delta X. Thus delta Y shows the amount of Y which the consumer has to give up for delta X increase in X if he is to remain on the same IC. Therefore it follows that MRS is AS by SB or delta Y by delta X. The change in Y in order to increase or cause a change in X by 1 unit. Typically it's 1. Okay, now suppose that points A and B are very close to each other, such that it can be assumed that both of them lie on the tangent T T. Okay. Now on the right angled triangle ASB, AS by SV equal to the tangent of the angle ASB. Okay. Uh, Tangent ASB. Okay, this one. It therefore follows that MRSXY is equal to AS by SV, delta Y by delta X, tangent of angle ASB. Okay. But in figure 8.3, angle ABS equals to TTO. ABS, this angle, is equal to TTO. TTO. Okay, this one. Hence, MRSXY is equal to the tangent of angle TTO. Okay, tangent of angle TTO, this one. Thus, but the tangent of TTO is equal to OT by OT, right? OT by OT. Okay. Thus, tangent of angle TTO indicates the slope of tangent line TT drawn at the point AB on the indifference curve. In other words, the slope of indifference curve of point A or B is equal to tangent of angle TTO. It therefore follows that MRSXY is equal to the tangent TTO is equal to the slope of the indifference curve on A or B is equal to OT by OT. It is thus clear from above that if we have to find out MRSXY at a point on the indifference curve, we can do so by drawing a tangent at the point on the indifference curve and then measure the slope by estimating the value of tangent on the angle which the tangent line makes on the x-axis. Pretty intuitive uh, in itself from the diagram. Principle of diminishing MRS. An important principle of economic theory is the marginal rate of substitution of x for y diminishes as more and more of good x is substituted for more and more of good y. In other words, as the consumer has more of good x, he is prepared to forego less and less of good y. As the principles of diminishing MRS is illustrated in figure 8.4. Okay, this one. Diminishing MRS. Okay. The marginal rate of substitution falls uh, is so evident from the table 8.2 in the beginning of marginal rate of substitution of x for y is 4 and then it becomes 3 and then we saw it fall down, right? Between b to c it's 3, c to d it's 2 and finally d to e it's 1. It means that in table 8.2 that the consumer stock of x increases and his stock of y decreases. He is willing to forego less and less of y for a given increment on x. Okay, so as he keeps on substituting y for x, um, he is ready to forego less and less because the amount of y with him now is uh, becoming less and less, so it's becoming dearer and dearer to him. In other words, MRS of x and y falls as the consumer has more of x and less of y. That is, the marginal rate of substitution of x and y diminishes can also be known from drawing tangents at different points in the IC. As explained above, MRS at a point on the indifference curve is equal to the slope of the indifference curve at the point and can therefore be found out by measuring the slope of tangent drawn at that point. Three tangents DH, KL, MN are drawn on the points P, Q, R. Slope of tangent GH is equal to OG by OH. GH is OG by OH. Okay, change in Y, uh, the Y axis and then the X axis. And similarly for Q and R, it will be noticed that OK by OL is smaller than OG by OH and OM by ON is smaller than OK by OL. It follows that MRSXY diminishes as the consumer slides down on the indifference curve. Okay. Reasons for diminishing MRSXY. Now the question is what accounts for the diminishing MRS. In other words, Why is it that the consumer is willing to give up less and less of y for a given increment in x as he slides down the curve? The following three factors are responsible. First, the want of a particular consumer is satiable, particular good is satiable, so that as a consumer has more and more of the intensity of his want for that good goes on declining. So as uh, if if he gets more and more of x which he wanted to get and was ready to substitute y for that 1 unit of x, as he gets more and more of that x, his intensity to want more of that good is now declining. It is because of the fall in the intensity of want for good x, goods say x, that when its stock increases with the consumer, he's prepared to forego less and less of y for every increment of x. In the beginning, when the consumer stock of Y is relatively large and stock of X is relatively small, consumers MR marginal significance for good X is low, when while his marginal significance of good X is high. So initially, his when he had more of Y and less of good X, his significance for Y was low because he had a lot of it. Owing to higher marginal significance of X and lower marginal significance of good Y in the beginning, the consumer will be willing to give up larger amounts of X for 1 unit of X because his marginal significance of Y was low initially. But as the stock of X keeps on increasing, intensity or desire for it falls, his marginal significance is also going to fall. And on the other hand, as a good Y decreases, and its intensity or desire for it increases, his margin significance of good y will go up. As a result, therefore, the individual substitutes more and more of x for y. He is prepared to give up less and less of y for 1 unit increase in x. The second reason for the decline in marginal rate of substitution is that goods are imperfect substitutes of each other. If two goods are perfect substitutes of each other, then they are to be regarded as one and the same good, and therefore increase in the quantity of one and decrease in the quantity of other would not make any difference because they're essentially the same, right? Because they're perfect substitutes. Um, and would not make any difference in the marginal significance of the goods. Thus, in case of perfect substitutability of goods, the increase and decrease will be virtually in the same good, which cancels out, and therefore the marginal rate of substitution remains the same and does not decline. Again, very intuitive, that the goods have to be imperfect substitutes of each other in order for MRS to be diminishing. Relationship between MRS and marginal utilities. It can be shown mathematically that MRS between goods is equal to the ratio of marginal utilities of goods X and good Y. An indifference curve can be represented as this, where A is a constant utility along an indifference curve. Okay, this A basically shows that utility is constant along that indifference curve. Taking total differentiation of one above, you get delta u by delta x dx plus delta u by delta y dy. So this, for this you need to know some level of differentiation. You are Because u is a function of both x and y, first you differentiate in terms of x, okay, and then you differentiate that x itself, then you get to y, and then you differentiate that y, okay. So now the dy by dx becomes du by dx divided by delta u by delta x divided by delta u by delta y. Delta u by delta x and delta u by delta y are marginal utilities of goods x and y respectively, okay. They are marginal utilities of x and y because you're differentiating utility with respect to each of them. Thus dy by dx is equal to marginal utility of x divided by marginal utility of y. Dy by dx is the slope of indifference curve and represents MRS xy. Du by dy is MRS xy. So this is the final uh, equation, okay. So MRS is basically equal to the marginal utility of good x to the marginal utility of good y. We now proceed to deduce from the above mentioned assumptions the important properties of typical indifference curves. Property 1: indifference curve slope downward to the right. This property implies that ICs are negatively sloped. This property follows from assumption 1. Indifference curves being downward sloping means that when the amount of good one is in the combination is increased, the amount of the other good has to be decreased. Yeah. This must be so if the level of satisfaction is to remain the same on the IC. Um, Level of satisfaction has to remain the same on the IC. If, for instance, the amount of good X is increased in the combination while the amount of good Y remains unchanged, the new combination will be preferred to the original one, and the two commodities will not therefore lie in the same IC. So, for this to happen, it has to be on the same IC. Okay. Property 2, indifference curves are convex to the origin. ICs are usually convex to the origin. In other words, the indifference curves are relatively flatter on the right hand portion, are relatively steeper to the left hand portion. Okay, so like this. So this is steeper, this is flatter. Should I draw this to show? Okay, so ICs are like this. If I also have to sort of draw the okay, not the best for annotations. Okay, so you see that this is steeper to the left hand side, whereas it comes flatter to the right hand side. This is what it means by saying that ICs are convex. The property of indifference curve follows from the assumption 3, which is that the marginal rate of substitution of good X and Y is diminishing as more and more of good X is substituted for Y. Only a convex IC can mean a diminishing rate of marginal rate of substitution for X and Y. If ICs were convex to the origin, it would imply that the marginal rate of substitution of good X for Y increased as more and more X was substituted for Y. As shown in figure 8.4, when the ICs are convex, MRS XY diminishes as more and more of X is substituted for Y. We therefore conclude that ICs are generally convex to the origin. Our assumption regarding diminishing MRSXY and the convexity of ICs is based upon the observation of actual behavior of normal consumers. If ICs were concave or straight lines, the consumer would come to monomania, that is, he would buy and consume only one good. We know that consumers in the actual world do not generally buy and consume one good. It is for this reason that we reject ICs of concave or straight line shapes and assume that ICs are normally convex to the origin. The degree of convexity of an IC depends on the rate of fall in um, MRS of X and Y. Okay, so degree of how concave an IC will be depends on uh, the rate of fall, of course, right? So what is delta Y by delta X? As stated above, when two goods are perfect substitutes of each other, the ICs are straight lines on which MRS remains constant. The better substitutes the two goods are for each other, the closer the ICs approach to the straight line, so that when the two goods are perfect substitutes, the ICs are IC is a straight line. We'll see all of this in the next part of this very chapter. So hold on. Okay. Property 3, indifference curves cannot intersect each other. Third important property is that they cannot intersect each other. IC will pass through a point in the indifference map. This property can be easily proved by first making the two indifference curves cut each other and then show the absurdity of self-contradictory result it leads to. Take a point A on IC2, okay, this one, and B on IC1 is vertically lower uh, below A, right? Since an IC represents those combination of two commodities which give equal satisfaction to the consumer, the combination represented by A and C will give equal satisfaction, right? While because they both lie on IC2, this one, okay. Likewise, combinations B and C are going to give equal satisfaction. Both lie on the same IC1, this one, right? If combination A is equal to combination C in terms of satisfaction, and combination B is equal to combination C, then we have to it has to be the case that A and B are also on the same level of satisfaction, but this is not the case because B lies below A. Okay, and hence this absurdity helps us to prove the fact that they cannot cross each other. This is just treated here. uh, okay, this one also is that ICs cannot even meet or touch each other or be tangential to each other. The meeting of two ICs of a point will also lead us to an absurd conclusion. The same argument holds. A higher IC represents a higher level of satisfaction than a lower IC, already pointed out. Combinations which lie on higher ICs will be preferred to combinations which lie on lower ICs. Combination Q on IC2 will give a consumer more satisfaction than combination S on the lower IC, because the combination Q contains more of both goods X and Y than the combination S. Okay, so this contains this level, whereas this contains this level of good Y. So Q is better. Same for good X. And by transitivity assumption, he will prefer any other combination such as combination R on IC2. Okay, yeah. Indifference curves are perfect substitutes and perfect complements. The degree of convexity of the ICs depends on the rate of fall and marginal utility of X and Y as stated above. When two goods are perfect substitutes of each other, the IC is a straight line on which marginal rate of substitution remains constant because they are perfect substitutes. Straight line indifference curves of perfect substitutes are shown in 8.7. The better substitutes of two good are the closer the ICs approaches to the straight line, so that when two goods are perfect substitutes, the IC is a straight line. In case of perfect substitutes, the indifference curves are parallel straight lines because the consumer equally prefers the two goods and is willing to exchange one good for the other at a constant rate. As one moves along the straight line indifference curves of perfect substitutes, MRS of one good for another remains constant. Examples of goods are Dalda and Ras Vanaspati, Pepsi Cola and Coca Cola. The greater the fall in MRS, the greater the convexity of the IC. Uh, the less the ease with which two goods are substitutable for each other, the greater will be the fall in MRS. Two important points to note. At this extreme, when two goods cannot be substituted for each other, that is, when the two goods are perfect complements, the indifference curve will consist of two straight lines, right angled bent, which is convex to the origin. Perfect complementary goods are in a certain fixed ratio. That's how perfect complements will be. So whereas this point will be at so for this three goods are complemented with two three good X's are complemented with two good Y's, and this is where the point will be. So similarly 6 for 4, 9 for 6. Okay, uh, as will be seen in figure 8.8, the left hand portion of the ICs of perfect complement goods is a vertical line which indicates that infinite amount of y is necessary to substitute 1 unit of x, and the right hand side IC is a horizontal line, which means that an infinite amount of y is necessary to substitute 1 unit of x. All this means that two perfect complements are used in a certain fixed ratio, like I just mentioned, and cannot be substituted for each other. Okay. Complements are thus those goods which are used jointly in a fixed ratio in consumption, so that the consumption increases or decreases simultaneously. Pen and ink, right shoe and left shoe, automobile and petrol. So all of these things will be substituted one for one. So the point will be this, like this. Okay. Utility functions of perfect substitutes and perfect complements. General for perfect substitutes is this, uh, where x and y are quantities of x and y, and ab are some positive numbers that measure the value of goods to the consumer. The slope of indifference curve representing the above utility will be minus a by b. Okay. If the consumer is willing to substitute good x and y at a rate 1 to 1, the utility function will be x plus y, right? Because both a and b will in this case be 1 and 1. The indifference curve of such substitutes will be a 1-1 relationship, which is -1 ऐसे करके गिरेंगे, 1 to 1 1 to 1 ऐसे करके होंगे, ठीक है. Further, if a consumer is willing to accept 2 units of good y to compensate him for the loss of 1 unit of good x, then utility function of these two perfect substitutes can be like this. This means that good x is twice as valuable to the consumer than good x. Now this intuition needs to be learnt. Okay, so good x is twice as valuable to the consumer as good y, because he needs 2 units of good y for 1 unit of good x. Now the indifference curve will be -2. So my one point will be 1, the other point will be 2, and there will be a straight line joining the two of them. Besides, the square of quantities of the goods of perfect substitutes will also give us the same utility function, okay, because of monotonic transformation. Perfect complements. Um, Now, how can we describe the utility function of two perfect complements, such as left shoe and right shoe? In case of two perfect complements, a consumer considers the pair of shoes for wearing them. Therefore, in order to have complete pairs of shoes for wearing, a person must have a minimum number of right shoe, right? Because if you have um, 4 of right shoe and 3 of left shoe, essentially the pair of shoes that you can wear is only 3. So the minimum number uh, of right shoes, because in case of shoes, one right shoe and one left shoe constitute a pair of wearing them. There is a 1-to-1 relationship between right shoe and left shoe. The utility function is going to be this. For example, if a person has a bundle of 5 right shoes and 5 left shoes, the utility function will be this. If a person is given with one more unit of right shoe, then the utility will not increase because the left shoe is not available, and so minimum of 6 and 5 will again be 5. Therefore, the extra one right shoe, keeping the number of left shoes remaining the same, will not cause any increase in the utility of the person. In above cases of complements relating to when there is a 1-to-1 relation of the two perfect complements. However, there are cases of perfect complements when the consumer consumes goods in proportion other than 1-to-1. For example, consider a consumer who always uses 2 teaspoons of sugar with each cup of tea. So this is going to be given by x half y. Okay, in this case of perfect complement, utility function can be written as this. In general, the utility of two perfect complements can be written as this is going to be the general case: ax plus by ka minimum, where a and b are the proportions in which the two goods are consumed.